Are rogue planets already in our solar system? I don't know about you, but if I'm told that billions of planets are freely roaming around in our galaxy, I start to feel slightly nervous. Because it's one thing for small asteroids, interstellar wanderers such as Oumuamua, for example, to come into your house, into our solar system, and take a ride and then leave without doing any damage. It's quite another to think that a large planet might come in like a cannonball that would also be capable of disrupting orbits, if not doing much worse. You are wondering what the hell we're talking about. Well, what about what certain astronomers are going around saying, convinced that such planets should not be considered a very rare freak of nature, as was the cause until a couple of years ago, but the result of a cosmic mechanism that in our galaxy acts on a large scale, and that of these starless planets is capable of churning out hundreds of billions of them. So am I right or wrong to feel a tad worried? I had always struggled with complex and challenging math equations, and then I found Brilliant. Now I can solve many more equations than I used to, while understanding the process and the reasoning at the same time. Brilliant is the best way to learn math, science, and computer science interactively. The hands-on learning approach that Brilliant offers is undoubtedly the perfect way of learning new and complicated stuff. It does not matter if you are a beginner or an advanced learner. Brilliant has thousands of lessons on STEM from basics to advanced, with exclusive new content added monthly. Besides solving math equations, I'm actually interested in a lot of other things, like data science. I'm learning a little every day on Brilliant, and who knows, maybe I will utilize the courses on my own YouTube channel. And on top of that, I have realized there's no need to spend 4 years and a load of money in college just to understand things that I can do here on Brilliant, while spending only a small amount of time and money. You can also start using Brilliant and get access to courses designed by professionals and improve your learning to a greater extent. Get started for free, and hurry, the first 200 people get 20% off an annual premium subscription by using the dedicated link brilliant.org/insane curiosity. They call them many things: wandering planets, orphan planets, floating planets, free planets, interstellar planets, and even rogue planets, the term that is most in vogue. They are worlds without a home. They have no sunrises or sunsets, because unlike the planets with which we are most familiar, these lonely worlds are not tethered to a star. Instead, they travel in solitary orbits around the core of the Milky Way. The galaxy has billions of them adrift in the perpetual night. They are orphans, driven from their parent stars during the chaotic birth of their native solar systems. Imagine a world where the sun has not risen for millions or billions of years, or perhaps at all. This has been talked about for a long time, but only a little over a decade ago did we begin to have evidence of their existence. At first, they might have appeared merely as a curiosity, but then someone began to do the math, relating the small number of objects that were gradually being discovered to the enormous difficulty in detecting worlds that emit neither light nor heat against the equally dark background of the space they traverse. And the numbers began to grow. In September of 2020, astronomers reported the detection for the first time of a rogue planet of Earth mass. And in December of 2021, the largest group of rogue planets ever was discovered, consisting of at least 170 objects ranging in mass from 4 to 13 Jovian masses. But what techniques are being used to succeed in identifying such elusive objects? The research, more than anything else, exploits the gravitational microlensing technique, based on an astrophysical phenomenon predicted by the general theory of relativity. Indeed, we can say that in the case of the search for interstellar planets ejected from their own solar system, the gravitational microlens technique is the only one that can be used. Such objects do not shine like stars and are often very cold objects, emitting too little heat to be seen by infrared telescopes. All that can reveal their presence lies in catching the moment when they randomly occult or nearly occult the light of a more distant star. When this happens, the planet acts as a gravitational lens, causing the star's brightness to increase. The chances of observing microlensing events are minimal because the three objects The star, the planet, and the observer must be perfectly aligned. The microlensing signal lasts only a few hours to a couple of days, then disappears forever. And this is what makes the phenomenon difficult to observe from Earth, even with multiple telescopes. But where do they come from, and how do they originate? And this is the most obvious question astronomers have asked themselves. At present, there are two hypotheses, possibly both correct. The first is that such planets were ejected from solar systems at a young age, when the large planets had not yet stabilized on orbits that they would later maintain for billions of years. We are accustomed to seeing our solar system as a collection of objects born as we see it today, with planets traveling in regular orbits well spaced apart. It sounds like heaven in celestial mechanics, but it is not quite so. The present planets are merely the survivors of a real gravitational struggle for survival. From the shapeless original nebula, it is very likely, in fact, that a far greater number of planets were formed than at present, most of which were then expelled from the system by deadly cosmic caroms. The theory suggests that planets of lower mass, such as Earth, would be more likely to be ejected from their star systems. Consequently, they should be much more common and numerous than the wandering Jupiters. In fact, according to numerical simulations, for every solar system like ours, there should be at least one gas giant and a dozen or so smaller rocky worlds that are ejected into interstellar space, where they will wander homelessly through the galaxy. Already, this tells us that the number of homeless planets should be at least comparable to the number of all the planets in the galaxy that regularly orbit a star. But we are only considering orphans, planets that once had a home around the star and were separated from their parent star by the gravitational pull of their siblings. Out there, however, could be a great many other planets of different origins, those that a parent star never even knew. In fact, another hypothesis entirely compatible with the first dismantles another cliché in our perception of certain astrophysical mechanisms. In all school and popular books, it is written that the formation of planets must be considered a mere consequence of the birth of a star from the condensation of a massive rotating hydrogen cloud. But whoever said that this must always be the case? When gas and dust begin to condense within a star-forming region, it is as if there is a continuous struggle between the force of gravity, which works to form as many stars of as great a mass as possible, and the radiation from the firstborn stars, which blow away the gas and ends their growth, and also that of any nearby protostars. When we look at a newly born star cluster, such as Pleiades, our eyes tells us that in that case gravity won. But this conclusion is a deception. For every hot blue massive star we see, there are generally hundreds or even thousands of protostars that will never make it to the mass needed to trigger the nuclear furnace and become real stars. Thus, amazingly, billions of aborted stars turn into planets, objects that do not find a star to aggregate with and then slowly end up scattering across the galaxy. Hang on a sec, guys, before we continue. Be sure to join the Insane Curiosity channel. Click on the bell. You will help us to make products of even higher quality. Okay, but whether they are of one origin or the other, can the approximate total number of such objects be quantified? The question is appropriate, but the answer obviously can only be very vague. Indeed, the casuistry is still very limited, so much so that current estimates vary quite a bit. Based on what we currently know, we can only say that the total number of wandering planets in our galaxy probably exceeds the number of stars by a factor of between 100 and 100,000. As if to say that against a population of 400 billion stars, the number of rogue planets could range from a minimum of 40 trillion to the incredible figure of 40 million billion. Really scary numbers, right? Now tell me, was I right or wrong to say I was worried about the safety of our solar system? To verify, let's try to do the math. The galaxy is a disk about 100 light-years in diameter and about 2,500 light-years thick. Let's do a default calculation and exclude the central bulge. The volume of the galaxy is that of a cylinder with a radius of 50,000 light-years and a height of 2,500 light-years. So the volume of the galaxy is just under 20 trillion cubic light-years. If the right estimate were that of 40 trillion planets, then it would mean that, at a minimum, in a volume of 1 light-year, we would find on average 2 rogue planets merrily going about their business, perhaps going the wrong way. If, on the other hand, we were to consider the higher estimate, well, in a cubic light-year, we should expect to find as many as 200 of them. This also means that right now a rogue planet could be less than 35,000 astronomical units from the Sun, largely within the Oort cloud and thus already in the airspace of the solar system. Remember the story of Mongo, the planet that in the famous Flash Gordon saga appeared out of nowhere to destroy Earth? Should we expect something similar? Who knows? Alternatively, we would also have to wonder, might not the Planet 9 hypothesized and sought by Mike Brown be a rogue planet? And on this, we would love to hear your opinion as well. But what might conditions be like for one of these space wanderers? We won't know for sure until we study some of them closely, but there are some assumptions to be made based on what we already know from observing the planets, dwarf planets, and moons in our solar system. Could they have day and night? No, as we already know, our daylight is generated by our position relative to the Sun. Without that sun nearby, there is no daylight as we know it. Could they have an atmosphere? Yes, it's entirely possible for a rogue planet to have an atmosphere, provided it is sufficiently massive. Even our little Pluto manages to maintain one, albeit a thin one. So yes, a planet orphaned of its star could also have a dense gaseous cover. What climate might they have? Let's just say that if you want to visit the surface of a rogue planet, you better pack a nice heavy jacket. Without the caloric supply of a nearby star, in fact, things could get cold pretty quickly. But that doesn't mean that every rogue planet has to be an icy world with temperatures close to absolute zero. In rocky planets, there may be, in fact, other sources of internal heat, such as residual energy from the violent formation process, movement in the core that creates friction, and the decay of radioactive elements. Could they have water? Yes, why not? We've also found water ice on Mars, and we have indirect evidence for the existence of subterranean oceans on icy moons in the outer solar system. It is therefore very likely that many of the nomadic planets also retain traces of it. What about life? Could some primitive form of life exist on their surfaces? Well, it might seem futile to look for life in such cold and desolate environments, but in recent years, astronomers have come up with several possible scenarios that would make life possible even on a planet orphaned by its own star. According to some, planets the size of Earth or larger might still have the possibility of harboring life, thanks to their internal heat sources. And if any of these planets were massive enough to afford a major atmosphere, this minimal heat supply could be conserved enough to allow the existence of bacterial life. The best atmospheric gas in this respect is hydrogen. Hydrogen is a very efficient thermal blanket and, as a bonus, does not condense, but remains gaseous even at the ridiculously low temperatures of space. A rogue planet with a dense hydrogen atmosphere could maintain its surface temperature above the freezing point of water. The planet could have lakes and oceans, and perhaps life on its surface, but its atmosphere would have to be at least 10 to 100 times thicker than Earth's. Nothing is impossible, however, for a category of objects that can number in the hundreds of billions. Life, as we well know, tries and tries again, and always manages to find a way to triumph in the end. All the more reason to look at space as an archipelago of lush islands, and not as an ominous expanse of stormy waters. Do you also agree?